G'day again, guys. Welcome back to In My Shed. I'm BC. I did that little story on taps yesterday, but I realised today I didn't make any sparks, so it wasn't a very exciting show. I'm going to give you a look at a very old tap grinding attachment. I've had it up there before, but I haven't shown changing the cam, and there'd be a lot of guys who'd be interested in seeing the setup that haven't seen it before. But I've been thinking today, I know this is a dinosaur machine shop, but it's for a good reason. All these things are still working. My lathe is 1985, the mill about 1980, the borer 1965, it's just 6 years younger than me, radial arm drill about 1970, cylindrical grinder 1965, the shaper 75, Haro tool grinder about 1970. This old girl here has no markings on it, my former leaf grinding attachment, but I would say mid-1960s, and the tap grinding attachment that I'll be showing you is probably 1950s, my age. And the thing about these old bits of iron is they still work. The thing that lets a lot of it down is the rubber insulation on some of the wiring, and I've got that issue with the Kearns borer, and that'll be a project you'll see in a couple of weeks' time. I've got a direct online starter box coming for the Haro, and if that seems to be good, I'll get another one for the Kearns. But you know, the materials are very, very basic, just really good tool steel and hard as glass, and they just last. And so bloody simple to set up and use. I'm just amazed at the stuff you buy now, you pay big dollars for it, and it's bloody shite. And it's not much more difficult for the factories to make something really outstanding and good. If you can make something outstanding and good like this Jones and Shipman cylindrical grinder in the mid-1960s with no CNC machinery, just all experienced tradesmen, good machine tools in the shop, why can't we get something like that now? When I got the Kearns horizontal borer, I believe one of the TAFE colleges took all their old dinosaur machines out and put a whole lot of new Chinese machines in, and they were going to teach precision machining in a pig's eye. You know, it's just not going to happen. Anyway, enough ranting for me. I'll bring you closer in and I'll show you changing the cam in this tap grinding attachment and a bit about how it operates. Bring you back in soon. Okay, fellas, this is the Hero. Very, very old and very simple. I'll just quickly change glasses. That is the control or operating knob. That's the cam, marked R for rat or right hand. That's got to be facing the knob. Come on, you old beastie. That's the 6-lobe cam that was going to be used on that big tap yesterday. This is the 4-lobe cam with R for rat facing out. Okay. No, it's not okay. The shaft has slipped out. That's a little bit better. Yep. Okay. Keyways aligned. On the control knob. Oh, sorry, show you how the pin runs. That's the most exciting part of it. The beauty of these old attachments is they're so simple. This is the operating rod that goes down to the lever attached to the camshaft. Here's the cam, and there's a little pin. And as you rotate the shaft, the cam forces the pin to move down. So dead easy mechanism. And that's part of making these things last forever. Keep it simple. A fair while ago I showed a Alfred Herbert chaser grinding jig, and instead of having a tilting mechanism, you just move the body of the grinding jig from one side of the base to the other, and that set the angle. And about 10 years later they brought one out with a pivoting mechanism that would wear, and I thought, geez, the first one was perfect, why the hell did you bloody change it? Anyway, that's changed over. I'll mount that up onto the tool and cutter grinder, swing you around and show you the setup. Okay guys, this is the attachment set up on the tool and cutter grinder. Now, all of these attachments have one thing in common, it's as far as I know, it's in the setting up procedure. You'll see the cam operating on the pin on this little lever in the back there. Yep, I think that's visible. That turns the second shaft over the back, which has a V cut into it. That V rotates. The vertical part of the V pushes on a push rod. That comes up to the setting dial, and that setting dial is a cap that screws in and out to control how far the effective push of that rod is. And as you turn the handle, it's almost imperceptible, but that pushing of the rod causes everything to pivot around this pivot point, and the whole attachment tilts up and away from the grinding wheel. Now, when you set the cam up, you set it up with the cam up against the push rod, and then over the back you have the fore and aft cutting edges, that's that cutting edge and that one, vertical at 90 degrees to the base of the table. So as you rotate the cam and the cutting edge comes in contact with the wheel, it's now pushing the attachment away from the wheel. And just as you go off the cam, it skips into the next gap between the flutes. So fairly simple. The form relief grinder works on a very simple principle, a similar principle. Now, where it says tap, that's just a thumb screw. There's a sliding V block there, and a center in there, and a center there. And this only works with tap that have center both ends, although you could use a reverse center on this end if you had to. And you put the tap between the centers, lock that up, and that locks the tap to the head. Then you turn over to the other side, and that knurled screw says set. Now if you undo that, that allows the head to freewheel on the main spindle. So you put it on set, put the flutes where you want them, and then you lock that up, and the head is now locked to the main shaft. So really simple design, as old as me, still works. And I learned something today: if you put the table clamp over the gib strip, you can't move the table. Silly old goat. I'll try and set up the GoPro so we can get a bit of filming of the actual grinding from a close-up angle. If I can get that to work, I'll set it up as the last clip in the video. Okay, bring you back in a sec. Okay guys, let's hope I can get this to work. We'll feed about 1 hour. Now I've got the traverse along the width of the wheel, so it's only a 1/4 inch wide wheel. Now if you'll note here, we're grinding at the trailing edge of the flute. Okay, I've set it up wrong. We're grinding at the leading edge of the flute first. I'll reset it. I think I've set it up a little bit better now. So in another 1 hour. There I've managed to match the previous timing. You can see that by the whole land being ground. Now in another thou. I'd say by the looks that I haven't matched the lead angle perfectly. And there you have it. All of the effective cutting flutes have been resharpened. It feels razor sharp. About the only thing you could do to improve it would be race up the flute with a cartridge roll. I don't like to use the amount of points in there because a little bit coarse in the striations could make the cutting edge fail. Okay, I'll get a box of cartridge rolls and show you what they look like. Okay guys, I managed to find a cartridge roll. That is the cartridge roll. It's a spiral wound tube of abrasives, usually slightly tapered towards the front, and that is the mandrel that it sits on to go into a die grinder. And the reason I like these is because they'll give a polishing effect. They won't take much material off. You should come in from the other end. You run up the flute and they will provide very, very short or narrow striations. This means the scratches aren't too big. We'll see if I can bring it in from that, rather than that way. Now that diameter almost perfectly matches the hook of the flute. So you're not going to change the dimensions of the tap or the geometry, and it should come up fairly good. So that's one old tap, probably that I'll never use. I think it's 7/8 UNC or something like that. Yeah, no, 7/8 Whitworth. So it's just something to demonstrate this grinding effort, but you can see that the relief on the lands is complete and ground very, very well. And when you get a lot of relief at this back end here, it'll be narrower than at the front end. So I think I've matched the original geometry fairly well, although not in the actual taper of the tap. Well guys, that's all for today. Cartridge rolls are a very, very handy item. I would say just as useful as spiral bands, but not quite as aggressive as spiral bands. And I used to carry these in 36, 60, 80 and 180 grit, and their price is quite acceptable. I think that would be about $2.45, and they last really, really well. You can grind up on angles with them, and you can marble the surface by putting them in a drill press and just move your bit of sheet underneath them. So quite a good item. Okay, grinding taps. That is one way, an axial relief attachment, similar to the drill and tap attachment that I showed a series on building about a year and a half ago, I think. That is another way to do it. For the cam is just a bit of flat plate in that case, or the large relief grinding attachment that I showed a series on about 6 months ago. That big fat boy has been moved on to a fellow over in Perth who set up a grinding shop and didn't have any relief grinding attachments. Okay, please like and subscribe. Every bit helps. And throw some questions at me if you want. Bye, guys.